When you drag a steel knife across a properly fried piece of fish, you should hear a distinct hollow rasp. That sound is the auditory signature of a flawlessly golden, shattering crust. But far too often, that crisp snap is replaced by a dull thud. Instead of a light, airy shell, you get a thick, doughy layer of soggy batter encasing the fish, served alongside a pile of heavy, grease-logged potatoes. The pursuit of the perfect fry has roots deep in British street food, where vendors originally wrapped hot fish and chips in newspaper to feed the working class. Recreating that perfection today requires abandoning old kitchen habits and focusing on raw materials. You need thick white fish, a high smoke point oil like canola or peanut, rice flour, and two specific liquids, cold lager and vodka. You also need precise hardware. Attempting this without a deep fry thermometer and an elevated wire cooling rack leaves you completely blind to the thermal reactions happening in the pot. Relying on a chef's intuition to guess when the oil is ready simply does not work. Consistently achieving a shattering crust requires treating the cooking process as an exact thermodynamic equation. We start with the potato. The objective of the triple-cooked chip method is to maximize the surface area of the potato before it ever touches hot oil. Step 1 is a gentle parboil. You simmer the thick-cut potatoes in salted water, just until they become tender enough to yield to a fork. During this boil, exterior starches swell and physically break apart. The potatoes' smooth edges crack and expand, creating hundreds of deep microfissures along the surface. Once boiled, they must be removed and placed on a wire rack to air dry and cool completely. If you drop wet potatoes into hot oil, the water will block the oil from crisping the starch. Next comes the first fry. Lowering the cooled potatoes into oil at exactly 266 degrees Fahrenheit dehydrates the exterior without browning it. This low heat builds a preliminary rigid skin around those microfissures. The potatoes are cooled one final time before the high-heat fry. Dropping them into 356-degree oil rapidly browns that dehydrated skin, giving you the final golden color and intense crunch. Because the parboiling created so many fissures, the surface area exposed to the oil is massive. This forms a glass-like exterior crust that traps the oil on the outside, ensuring the interior potato remains perfectly dry and fluffy. For the fish, the primary obstacle to a crisp coating is gluten. Traditional batters rely on water or milk, which combine with wheat flour, to form dense, elastic gluten networks that turn chewy and heavy when fried. To prevent gluten from forming, we replace the water entirely. Instead, the liquid base is made of equal parts cold lager and 80-proof vodka. This graph compares alcohol and water reacting to deep frying heat. Alcohol evaporates much faster and at a lower temperature. When vodka hits 375-degree oil, it violently vaporizes, blowing apart any small gluten networks. This rapid moisture loss leaves behind a highly aerated, structurally sound shell. We owe this specific chemical manipulation to Chef Heston Blumenthal, who introduced the vodka beer batter to solve the problem of dense, overcooked crusts. To maximize the aeration, Blumenthal discovered, the lager must stay capped until the exact moment you mix the batter. Every escaping bubble of carbonation is a pocket of air you are losing in your final crust. By swapping water for alcohol, the batter stops acting like a doughy breading. It becomes a temporary, self-dehydrating microstructure designed to crisp instantly. Even with the perfect batter, the fry will fail if the raw fish is wet. Residual surface moisture acts as a lubricant, causing the batter to slide right off the fillet the second it hits the oil. You have to aggressively dry the fillet with paper towels, then dust it completely in rice flour. That matte, floured surface acts as an adhesive primer, giving the wet batter a dry texture to grip. Before the fish goes in, check your thermometer. The oil must be holding steady between 350 and 375 degrees Fahrenheit. This animated dial tracks your oil's heat capacity. Watch the needle when cold, dense fish is introduced. The temperature plummets from the green crispy zone straight down into the red greasy zone. If you overcrowd the pan, the oil cannot recover, and food absorbs fat. To execute the drop, hold the battered fish by the tail. Gently lower it into the oil, laying it down facing away from your body. This locks the crust in place while directing any splashing oil toward the back of the stove. Stripping the moisture and holding a precise temperature range changes the physics of the pot. The hot oil instantly seals the batter, turning the crust into a protective steam chamber that gently cooks the fish inside. After 8 to 10 minutes, the crust will be deeply golden and the interior fish perfectly steamed. Now you have to extract it without ruining the architecture you just built. Do not place the hot fish directly onto a plate lined with paper towels. The residual heat from the fish generates steam, and a flat paper towel traps that moisture directly against the batter, turning the bottom into mush. Instead, transfer the fish to an elevated wire rack. This allows a full 360 degrees of airflow, letting the excess oil drip away while the steam dissipates harmlessly into the room. Once drained, the meal is ready for assembly. The shattering fish and the triple-cooked chips are plated together, traditionally accompanied by lemon wedges, tartar sauce, and malt vinegar. But remember the physics of moisture. Acidic liquids like malt vinegar are structurally dangerous to your crisp batter. Only shake them over the fish at the exact second you are ready to take a bite. Deep frying doesn't have to be a greasy guessing game. By applying strict temperature control, managing moisture, and manipulating evaporation, you elevate a humble street food into a precise, foolproof masterpiece.